Okay, so 7.5, we're going to solve exponential and log equations. The first little bitty section is going to be kind of review because we have already solved a few exponential equations, but then we're going to take it a little bit further. So review-wise, remember that if you have two exponential, or the same basis for an exponential equation, then you can just set the two exponents equal to each other. So as long as my bases are equal, then my exponents have to be equal. So all I would do is set 3x plus 1 equal to x plus 4 and solve for x. So I would subtract my x, get my x on one side and my constant on the other, so I would subtract my 1. And so that gives me 2x equals 3, divide by 2, and x equals 3 halves. Okay, so in 7.3, we manipulated bases so that we would have like bases in order to do that. So if I have 100 raised to the 7x plus 1 power equals 1,000 raised to the 3x minus 2 power, what can I get those bases to become?
Times
A
10.
10. Okay, so I can't make 1,000 become 100, but I can make both of these have a base of 10. But 10 to what power will give me 100? Okay, so 10 squared, and 10 squared is raised to the 7x plus 1. And then 10 to the third power is 1,000, so 10 to the third raised to the 3x minus 2. Okay, so what I need to do, I have a power to a power, so I multiply, I'm going to distribute that 2, and it becomes 10 to the 14x plus 2 power equals 10, distribute the 3, 9x minus 6. Now I have like bases. Now my exponents can be equal. So 14x plus 2 equals 9x minus 6. And then I'm going to solve for my x. So subtract your 9x. In the same step, you can subtract your 2. And that's going to give me 5x equals negative 8. Divide by 5 and x equals negative 8/5. Okay, we're good with that? Alright, so if I have 4 raised to the 2x plus 2 equals 64 raised to the x minus 2, I can make 64.
4 to the 3rd.
Mm-hmm. So then I'm going to distribute that 3, and I have 4 raised to the 2x plus 2 equals 4 raised to the 3x minus 6. So set 2x plus 2 equal to 3x minus 6. Get your variables on one side, constants on the other. If you subtract your 3x, you're going to have a negative x, which is fine. You'll just divide by negative 1. Or you can move your 2x to the 3 and your 6 over. Either way, you should get x equals 8. Okay, are we good manipulating that? Okay. So, what if you cannot manipulate it to become like bases? So if I had 4 to the x power equals 11. Okay, I cannot make an 11 a 4. I can't make an 11 a 2. Okay, so what you're going to do, this is exponential form, right? What's the inverse of that? Log, right? So when I give you an exponential equation that cannot be manipulated, you're going to take the log of both sides. Okay, so I'm going to take the log of 4 to the x power equals the log of 11. Okay, once I take the log of both sides, then I need to use my properties that we learned last class in 7.4. If I have an exponent, I need to bring that to the front. And so that gives me x times log of 4 equals my log of 11. Okay, well my goal is to solve for x. So x is being multiplied by log of 4. So I'm going to divide both sides by log of 4. So that leaves me with x equals, and I can take my calculator and I can evaluate Okay, so your log of 11 over your log of 4. So 1.730. Very good. Okay, when you divide by log, that's one term. You cannot cancel log and log to give me 11 over 4. I just want to emphasize that, okay? That is an expression that you can't just remove the word, okay? So my next example, I have 6 to the 3x plus 1 equals 8. Now, if I would have had, say, this and a minus 2 behind it equals 8, you would want to isolate this. We didn't put this in the notes. It's in the other sections, but I didn't put it in the notes. But if you have something where you have something added or subtracted behind this, then you just move that over before you take the log of both sides, okay? But here, I don't have that, so I'm just going to take the log of 6 raised to the 3x plus 1 power equals the log of 8. So then I can bring the entire 3x plus 1 forward. When you have a binomial as your exponent, you need to put that in parentheses when you bring it forward. Okay, so my goal is to get this x by itself. Before I can get it completely by itself, I need to get the 3x plus 1 by itself. So I'm going to divide both sides by log of 6. So 3x plus 1 stays on the left. And then log of 8 divided by log of 6.
That would be 0.703.
Mm-mm.
Oh, dang it.
So 1.161. So always round to 3 decimal places. Okay? And so now I'm to a normal solve for x. So I subtract 1. When I subtract 1, that just gives me 0.161. Then divide by 3. X is equal to 0.054. Good with that? Okay. All right. If instead of a number as my base, I have e as my base, yes.
What were you talking about earlier that had something added to it?
Like if I had 6, 3x plus 1 minus 5 equals 8. If I had that, I would want this by itself. So I would add my 5 to get this, and then I could take a log of both sides. Okay? So if I have e as my base raised to an exponent, remember the only thing that goes with e is natural log. Okay, so instead of log of both sides, I'm going to take natural log of both sides. But I want my e isolated. Whatever, so just like this, whatever your base is, you want that isolated. Okay? But a key property for this section is knowing the natural log of e is equal to 1. Okay? Remember last class, I had told y'all the log of base b raised to the b, not raised, but log base b of b is 1.
Yeah.
Right? Because b to the first power would equal your b, because it's log base solution equals exponent. So that is where the natural log of e gives you 1. Because what is this base understood to be?
Natural?
An e. That's understood to be e. So that is why the natural log of e is equal to 1. You have to memorize that. Okay? Do not forget that. That's going to be key to this section. So if I want e to the x by itself, I need to do what?
Add
I'm going to add 2. So e to the x is equal to 10. Now I can take the natural log of both sides. Now this x comes forward. But what do I know the natural log of e is?
1.
Alright, so that natural log of e is just 1. So I have x is equal to the natural log of 10, which I evaluate. So 2.303. Say that louder. Yeah, so if I give you exponential, you're taking logs. But if I give you logs, then you go back to exponential. As long as you get that down, this is easy. There's just a lot of different examples because a lot of people usually need the practice to get it down. All right, so if I have 4 times e to the negative 0.3x minus 7 equals 13.
First you gotta add the 7.
So I want the e by itself. So I'm going to add 7. And that's going to give me 20.
Divide by 4.
Yep. That's going to equal 5. Then I take the natural log of both sides. I'm going to move my exponent to the front, and in the same step, I know natural log of e is 1. So negative 0.3x equals natural log of 5. You can evaluate what natural log of 5 is, then divide by negative 0.3, or you can divide and type it all at once. So if you do that, you've got the natural log of 5 divided by negative 0.3. Negative 5.365. We good? All right, so now what if I give you the log or natural log? If I'm providing you the log or natural log, you want that isolated, then you're going to get it into exponential form, okay? So remember that your log is log base solution equals exponent, right? And so I can rewrite that. Exponential form is my base raised to the exponent equals my solution. So in 7.3, we had practice rewriting from one form to the other. Okay, so once you get your log or natural log isolated, like this one, then you need to put it in exponential form. So if I do that, my base is understood to be e. So log base e solution equals exponent, so e squared is equal to x. All right, so the value of e, if you do second log and go to natural log, that's option 2. So e squared x will equal 7.389. You do second log, go to natural log, and then the second one is my e. Yes. So the log base solution equals exponent. So the e is my base, this is my solution, and that's my exponent. So in that order that we did for 7.3. Alright, so now I've got natural log of 2 minus 3x plus 4 equals 7.
Of course, you gotta minus
I need the natural log by itself. So I'm going to subtract 4. The natural log of 2 minus 3x is equal to 3. Okay, I know my base is e, so I can put it in exponential form. E to the third power is equal to 2 minus 3x. So e cubed is 20.086. Equals 2 minus 3x. If I want to solve for x, I'm going to subtract my 2. Negative 3x equals 18.086. Then divide by negative 3. Very good. Okay. So, this whole time, technically, we're supposed to be plugging it in and checking answers. Those answers all worked out. Okay. When you're solving, on the notes and probably on the worksheet, they're going to be separated, exponential separated from log. Okay. But on your test, they're not going to be separated. Okay. So you need to know what to do when. So what I mean by that is if I give you exponential, you're going to solve using logs. If I give you logs, you're going to solve using exponential. Okay? You're supposed to check for extraneous solutions. That's really when you're doing logs. Okay? Because you cannot take the log of 0 or a negative number. Okay? So that is a rule you're going to have to know also. You cannot take the log of 0 or a negative number. So could we have been plugging all of this in this whole time? Yes. I just know they all work, so I just keep moving. But, for instance, how to check this. You're not necessarily, you could type this whole left side in, make sure it's equal to 7. But really what we're going to be doing when you have a log is you're going to take this x value and just see, am I taking the log of a negative or a 0? That's really what's going to create the extraneous solution. If it gives you a log of a negative or a log of a 0, then you mark through it. Okay? So, if I have 4 raised to the 2x minus 1 equals 8 raised to the x plus 2, I can do 2 things. I can do my like basis, or I could just take the log of both sides. You're just going to work more if you do log of both sides when you can get like basis. Okay? So here, my 8 is not going to become a 4, but it can become 2. Right? And my 4 can become 2, so that's what I would do. I would make 4 2 squared raised to the 2x minus 1, and I would make 8 2 cubed raised to the x plus 2. So then 2 to the 4x minus 2. Yes. You could go straight to this. Oh, you could go straight to these if you knew that. Just be careful because some people make mistakes. So 4x minus 2 is equal to 3x plus 6. I'm going to subtract my 3x, add your 2, x equals 8. Alright, so when I have 3 raised to the x plus 3 equals 5, I'm going to do log of both sides. So log of 3 raised to the x plus 3 equals log of 5. Then that x plus 3 comes forward. in parentheses, x plus 3 log of 3 equals log of 5. Okay, as a class, what do I do next?
Then you go divide log of 3 by log of 5.
Divide by log of 3.
Yeah, that's what I meant.
So x plus 3 equals very good. And then subtract 3. So x equals negative 1.535. So when you check it, okay, if you check, so I'm going to show you the difference here. I have my long number that I never cut off in my calculator. If I just stored that for x, and I were to type 3 raised to the x plus 3 power, I get my 5. But if I do negative 1.535 and I estimate it, I round it, I don't get exactly 5. That is okay, as long as it's near 5 because of your rounding. Okay, so this long decimal is my super accurate actual answer. So when I store that, of course it's going to give me 5. But if all you're doing is checking the rounded one, just make sure it's close enough to 5. You get what I'm saying there? Okay. Okay, next example. 10 to the 3x minus 1 plus 3 equals 3. I want 10 to the 3x minus 1 by itself, so I'm going to subtract 3. Yes. Okay, so I'm going to write out log of 10 to the 3x minus 1 equals log of 0. I need to see that before you tell me no solution. Okay, I cannot take the log of 0, so it makes it no solution. Okay, so let's say we do the next one. 7 to the 9x plus 3 equals 15. I want you to try to do that on your own. Y'all have an answer?
Yeah.
Your answer should be x equals 0.142. Did y'all get that? Do I need to work it out for anyone? Okay. So, if y'all can do that, we're skipping the next one. We're going to do this one when y'all get back. So this one and this one are pretty much the same steps. The only difference is what?
We're gonna multiply the two of those things? Never mind. Thought you were talking about the other one.
Okay, well,
What's natural?
natural log. Okay, so this would be a log, this would be a natural log. Okay. Now on this one though, I said we're gonna skip it, we're gonna do it. If you add your 14, you get 3e to the x equals 15. Okay, what am I doing then? Divide by 3. Okay, so as long as you understand you have to divide by 3 and you're not just taking the log of 3e to the x, then I'm good. You would end up getting e to the x equals 5. Then,
Transfer the natural on and the natural on.
so x equals natural log of 5 and whatever that value is. Okay, so as long as you got the steps down, we don't have to get the decimal for that one for time's sake. But I just want to make sure that y'all are good and realize that 3, you don't want to take the natural log of 3, you want just the e by itself. So my next one, I've got 2/3 e to the 2x minus 6 equals negative 3. So my first step is to add my 6. So 2/3 e to the 2x equals 3. Okay, to get rid of that 2/3, I'm going to do what?
Multiply
Multiply by 3/2. You do not divide by a fraction. So e to the 2x is equal to 9/2. Then I'm going to take the natural log of both sides. Bring my 2x forward. Natural log of e is 1. So 2x equals natural log of 9/2. You can just type in your calculator. 1.504. Then divide by 2. 0.752. Okay, you should be checking these when you do your homework, but they should all work out. Okay? So, now I'm switching gears and I'm giving you the log or the natural log. Alright, so your goal is to isolate the log as much as you can. Here, this first example, I don't have anything to do. So then I'm going to get it in exponential form. Okay, so if it is log base solution equals exponent, and I need to get it in exponential form, then how am I going to rewrite this? 2 to the 5th equals x minus 6. Okay, well 2 to the 5th is
32. 32.
So then add your 6 and x is equal to?
38.
Okay, so what you do to plug it in is you're going to take 38, and if I look, 38 minus 6, is that going to give me a positive number? Yes, so I'm good. Alright, if I have 2 log 6 of 2x minus 5 equals 4, I want my log by itself. I do not need to bring that 2 back to its exponent. I don't want to do that. Okay, so I can just divide everything by 2, and I have log base 6 of 2x minus 5 equals 2. Six squared equals 2x minus 5. So 2x minus 5 equals 36. Add your 5. 2x equals 41. Divide by 2 and x equals 41 halves. If you give me 20.5, then I'll be okay with that too. So if I were to plug that back in, do I get the log of a positive? Yes. Okay, now what happens when I have multiple logs? If I have log base 3 of 3x plus log base 3 of x equals 7, does that become log base 3 of 4x? No.
Yeah, no. 3x squared.
I need to multiply. So my properties from 7.4, when I add, that means I really multiply. So I'm taking log of 3 and I'm multiplying 3x times x equals 7. So when I rewrite it, I'm going to have 3 to the 7th power equals 3x squared. 3 to the 7th power is 2,187. And when I divide that by 3, I get 729. So then, yes, log base solution equals exponent. I rewrote it in exponential form. So then square root
27.
x equals plus or minus 27. Okay, so anytime you take the square root, you have a plus or minus. But you have to consider those as separate answers. X equals positive 27, x equals negative 27. Are they both my answer? No, I cannot have the negative 27 because it ends up taking the log of a negative when I plug it in to either one of these. Okay? So not necessarily is it just automatically not my answer because it's negative, because if I would have had a negative somewhere here, it would have ended up positive. So you have to be careful. Just plug it back in. Okay? So then I have log of 5x plus log of x minus 1 plus 2 equals 4. I'm going to combine my logs and subtract 2 in the same step. So it's an addition sign, so that means I'm going to multiply 5x times x minus 1 equals 2. Now I don't have a base written, so how am I going to put that in exponential form? It's understood to have a base of 10, so 10 squared is equal to 5x times x is 5x squared minus 5x. All I did was distribute. Okay, the moment you see an x squared with an x, I need to get it to ax squared plus or minus bx plus or minus c equals 0 so that I can factor. I didn't have to factor this last example because it was just an x squared and a constant. I could do square roots. But if I have x squared and x, I have to factor that. Alright, so I'm going to end up with 5x squared minus 5x. 10 squared is 100, right? I would have needed to subtract that, so minus 100 equals 0. You always want your x squared positive, okay? So then what can I do?
Divide by 5.
Yep, all of those can be divided by 5, so that leaves me with x squared minus x minus 20 equals 0. So x minus 5, x plus 4 equals 0. So that's going to lead me to x equals positive 5, x equals negative 4. Are they both my answer? Which one's my answer? And negative 4 would be extraneous. Okay, now what if I have two logs but they're on opposite sides? I can still move the entire log over to the right. It's a minus, so I need to add. So I would have log of 8x plus log of the x minus 20. That sign does not change. Okay, whatever is in the solution position for your log does not change. That is equal to 3. So then condense it. log of
8x minus 1
equals 3. Then exponential form, I have an understood 10 for my base, so 10 cubed is equal to 8x squared minus 160x. 10 cubed is 1,000, so I would be subtracting 1,000. So I have 8x squared minus 160x minus 1,000 equals 0. If 1,000 is divisible by 8,
is 125. Sorry.
if 1,000 is divisible by 8, then I can divide everything by 8. So then that gives me x squared minus
20.
minus
125.
Okay, so factors of 125 to give me a 20 would be 25 and 5. Okay, so I have x minus 25 and x plus 5 equals 0. So x equals positive 25 and x equals negative 5. 25 would be my answer, negative 5 would be extraneous because it would make it negative. It would be a log of a negative 40, which we can't have. Okay, now what if I have just log and log with no added nothing? Or natural log and natural log, no added anything. Then I can treat that like I do with like bases. Okay, so if I have natural log, I just set my 7x minus 4 equal to the 2x plus 11. So subtract your 2x, add your 4. If I plug x equals 3 back in, are they both positive? Yes. Okay, so then if I have natural log of 4x minus natural log of 3 equals 6.
You gotta divide 4x minus 3.
Okay, so my minus means I'm going to divide, so I've got a fraction, 4x over 3. Okay, now my natural log has a base of e. So when I put it in exponential form, that becomes e to the 6th is equal to 4x over 3. So e to the 6th is 403.429. How am I going to solve for x? Okay, you can either multiply by 3, then divide by 4, but you could also multiply by 3/4. Either way. And x is equal to 302.572. So then, natural log of negative 3x plus 1 equals natural log of 4x plus 4. What do I need to do?
Get the minus subtracted natural log of 4x.
So this 4x plus 4 is not one term. Notice that this has parentheses, whereas this does not. Okay, so this natural log of 4x is what I'm subtracting. So subtraction means I'm going to have a fraction. So my base is understood to be e, so when I write it in exponential form, I have e to the fourth is equal to negative 3x plus 1 over 4x. E to the fourth,
54.598.
so then how do I solve that? Put it over 1. You've got 2 fractions now. How can I solve when I have 2 equal fractions? Cross multiply. So 54.598 times 4 gives me 218.393. X equals negative 3x plus 1. So then I'm going to add my 3x. It gives me 221.393. X equals 1. Divide. .005. You would divide 1 by that decimal. Are we good with that? Do we have questions? Okay, you're going to have a quiz over this lesson. Okay, so all of solving. Know your exponential equations, know your log equations. Okay?